Hey there, in this presentation, I'm going to describe um, part of at the current time of recording, this is part of the PySpace physics theory. I regard it as an application of the PySpace physics theory, but it sort of sits, it's what I would term the applications, but it's to do with how one designs a thinking machine and the design principles to which one would have to implement in order to achieve a machine that would be said to be thinking. So this is just an introduction. The idea will be that I'll do a series of presentations on different aspects of the architectural design and what needs to be done. The idea will be to use the way human being is designed and other aspects of life, other kind of living beings, and describe how they work. So it's as much about how DNA does it as designing a machine. The design could be used for a car. It could be used for a plane. It could be used for any kind of object which requires some form of intelligence. So it doesn't have to be a machine, an android, but that's for the purposes of the document. That's just what I focus on because I try to have a retrospective view on the human being. So, the document is called "Design for Thinking Machine." It's on the PySpace at the time of recording. It's on the PySpace physics theory. If you search for it, you should find it. So, the document contains at the time of writing. This is the first draft. So what I have is in the first chapter I have a definition of what it is for being to be kind of alive, and I talk about things like the window in the mind and the way our vision system creates this impression of us being in a place and how it's all abstracted. I talk about the kind of high level kind of terminology like HOS for a human operating system and so on. I define the different terms, um, and then I discuss a physics engine that's in the mind, and that's where the PySpace theory comes into it. In chapter 2, I talk about DNA and how it works. Now, the idea of this document is to reverse engineer DNA into a form that is computationally efficient to kind of copy. So the idea is not to copy the exact form of the DNA in terms of the chromosomes. The idea is to abstract the design into a form that can be used on a computer system. So, but the idea is to try and understand how DNA functions and how it can be abstracted into a kind of a modern computer architecture. So there's descriptions of the physical person and the virtual person and so on. Chapter 3, I talk about the message algebra that's needed. Uh, there's a messaging system that needs to be implemented, and there's a thing that which is algebraic in nature. Later, I talk about the DNA, what I call DNA apps and messages. So this is my own particular take on DNA, like how do you make DNA kind of friendly to a programmer and so on. So we have to create our own version of it, and we have to kind of mimic its behavior and its extensibility. So here we talk about things like DNA containing apps and having messaging protocols, which is very familiar to computer people. Uh, in chapter 5, uh, I go into the kind of a lot of the well-known illnesses that human beings suffer from, people, including people that anyone would know, and in the same way that a doctor would use an illness as a way to figure out how the body works, we can then make assumptions about, well, this shows that if you design a computer system, you got to watch out for these things because in a human being, these are the things that cause people problems. So I go into that. After that, I cover what I call message balance, and this we enter the worlds of kind of Chinese medicine and qi and the nature of acupuncture and what's that all about. And the idea is to reinterpret what is acupuncture, like why does it work, and how could we use these principles to achieve message balance within a machine. And I discuss a variety of well-known human conditions like the placebo effect and things like that, and how could that work, and how could we take advantage of that design pattern in a machine. We then talk about the kind of more basic things that we all know about in a person or human being or living beings, the olfactory senses, the sense of smell, and then the brain and how things work, pheromones and the limbic system. So the idea of the document is there's a lot of descriptions of, um, brain diagrams and so on, and how the bits of the brain that do various jobs. An important part of the brain, of course, is vision. So I cover vision, and that's a big topic. And um, this this chapter deals with all of the things that the brain does for us for free, so to speak, at a genetic level, creating our sense of creating our sense of living and being in a place with 3 dimensions and all that good stuff. So I talk about that there. Chapter 9 is music and speech. We all know music. I don't need to describe it to anybody, but they're kind of trying to understand how does that work within a human being, like tempo and polyrhythmic beats and so on, and stuff that musicians kind of know, and how do you design a machine, or what would you even need a machine to be musical, and we show the benefits of the coordination of the different messaging and all that good stuff. So I talk about that here. On the chapter 10, I talk about self-awareness and sensors. I mean, this is kind of the stuff of um, being in a place and seeing it and experiencing it in 3 dimensions, but also feeling it. Temperature, position, orientation, and so on. All that stuff that if you were building a machine or any kind of an object that needed to keep itself upright, or in a room in a place with a certain temperature, all those things that pressure, one needs to kind of have a sense of that. So I talk about that in chapter 10 and this document. The chapters may change in position over time as I change it, but for now it's chapter 10. And then chapter 11 I talk about problems people suffer from in terms of their mental processing. And then the importance of memory and the importance of sleep, and why those things are important and how that works. And then there's the circadian rhythms, and why would a machine even need a circadian rhythm? Is there any need for a machine to have circadian rhythms? Or do you just pack stuff up and just process it continuously? Chapter 12, I talk about logic, reason, and math. This is your typical kind of maths approach to things. I explain how this can be achieved, the logic and so on, and how we could achieve that using sort of a messaging system. And I also talk about the evolution of speech and so on. In chapter 14, I cover body structure and muscle types. So in there, I discuss the physicality of a machine and the physicality of a person, and the importance of having these different pieces. Then I have an overall architecture of the system, and then I have several appendices, and they may change in terms of what they contain over time, but at the time of writing I have the idea of the software one would need. I don't have any written right now, but the design pattern is there, the hardware you'd need, the budget depending on your budget. Then I have a kind of a wish list of algebra types and apps, and then the message circuits that the brain kind of needs and how we could implement that. And then we'll talk about the senses and the message pairing. So one of the important design patterns in the document is how you pair message types, like you pair sound with vision, and in this case of this video, when it's made, you pair sound with vision. In the brain, it's doing something similar, and so on. So I have lists of different types of messages that are paired and the reason why you should do it. I have a prototype discussion. I haven't written any at the moment, but the architecture itself, calls for the need to do certain prototyping. And then I have a set of miscellaneous to-do tasks which change over time, and I have the goals and related behaviors. So that's it. That's the introduction to the theory. So I'm really just going to talk through the document, which may evolve over time, and so I'm going to just chat about the design goals and the kinds of things that you can try to achieve if you're designing an intelligent device, machine, or whatever. And I'm hoping this document may be of some use to someone who maybe needs to design something like this, and may give them some ideas for their own design. But this is the approach that I think would work, and as a sort of a computer science person, I think this would work, but it would require a lot of people. So mostly the initial steps will be just to describe the architecture at a high level, and that's it for now.